Hello, scholars. Let's practice using diagrams how we would be able to identify the ages using these relative age dating techniques. So here's our first one. We got some geologists. They've got safety going. That's awesome. Now, in this image, there is gneiss, an igneous dike, a nonconformity, and sandstone. And we want to figure out what is the oldest and what is the youngest. Well, the principle of superposition tells me that the sandstone is the youngest, and it's above the nonconformity, which is older than that. So we could look at these four and say sandstone youngest, nonconformity, then we've got the igneous dike and the gneiss. But since the gneiss is on either side of the igneous dike, then the igneous dike cuts across the gneiss, which means it is younger than gneiss. And gneiss. So we have four events: the gneiss, the dike, the nonconformity, the sandstone. And in order from oldest to youngest, it is that in particular: gneiss, dike, nonconformity, sandstone. Try this on your own. Freeze the video, look at the slide, check it out, see if you can recreate that. I'm going to keep going. So in this diagram, now we have A, B, C, D, and E. C, B, and A are sedimentary layers. D is an igneous dike, and E is a fault. Using the principle of cross-cutting relationships, E cuts across everything, so it must be the youngest. E cuts across D, but D cuts across A, B, and C. So we are going to say that E is the youngest, D is younger than E. This is cross-cutting we use to figure these out. And then C is the oldest, B is a little younger, and A is younger than B. So it's going to go A, B, C, and we've got these through superposition. Cool, right? What's the geologic history of this block diagram? Deposition of C, B, A, intrusion of the dike D, offset of the fault E. Wow, we're using the principles of relative age dating to understand the geologic history. Now, I know this is a simplified diagram. Earth is much more complex, but we've got to start somewhere for our learning to begin, and this is where we're at. Okay, so now we've got what? F, E, D, C, B, J, G, A, I, H. What the heck is going on here? Well, let's use our principles. So I looks like it's surface erosion. It's on top. It cuts everything off. I is the youngest. This is going to be surface erosion. Okay. G is an igneous dike, cuts across all the layers, cuts across this fault, cuts across this igneous intrusion here. So G is going to be the next young. Cross-cutting. G cuts across H. H cuts across all of these layers. A cuts across all of these layers also. So we're actually at an impasse. What was next, H or A? It could be either of these, A or H. These are both interchangeable, and they're cross-cutting. Now, what do they cut across? Well, they cut across all these rock layers: horizontal, continuous, and aged from oldest to youngest, bottom to top. So it's J, B, C, D, E, F. Now we're going to go J, B, C, D, E, F. And these are all now superposition. It's really nice when you get to look down into the side of the Earth, which isn't always the case, but using outcrops and exposures and little bits and pieces of evidence that we see at the surface, this is what geologists do. They recreate geologic histories based on the sequence of events from the information that is available for them. So this was our attempt to practice how do we apply Steno's principles of stratigraphy into understanding the relative ages of rocks in a stratigraphic sequence. Thank you.